Hey everybody, we're going to be graphing linear equations today. So what it means to graph a linear equations is we're going to be using an equation that looks like this, and when we graph it, it actually forms a line. So let's talk about this equation that we've started off with here, y equals 2/3 x plus 3. This equation falls perfectly in line with our standard equation that we'll be using to graph lines or linear equations, which looks like this. Y equals mx plus b. Where m, in our example, would be the 2/3. And b, in our example, would be the 3. So each of these things, the m and the b, have a job to do. So let's talk about what the b does first. In our example, our b is this positive 3 right here. The positive 3, or this b value, tells us where this line that we're about to draw intersects the y-axis. So it literally crosses over the y-axis, and in our example, this line crosses the y-axis at positive 3. So we've already found one point that sits on our line. Now we need just one more point. We'll connect those dots and we'll graph our line. So we're going to find our second point by using the m value, the 2/3. So the m value is actually what's called the slope of the line. So basically the steepness of our line. So let's go ahead and write the 2/3 off to the side and determine what each of these numbers does. The 2 is your up or down movement. So since it's a positive 2, from this point we will be going up 2 units. Then the 3 determines the left or the right movement. And since we have a positive 3, we'll be moving to the right 3 units. So from our starting point right here, we are going to go up 2 units and over 3 units. What that did for us is it created a second point that we can now use to graph our line. So let me go ahead and draw our lines, extend through those 2 points. And there is the line y equals 2/3 x plus 3. Okay, let's go ahead and take a look at another one. Here we have the line y equals x minus 5. So again, this 5, or actually this negative 5, has a job to do. If you'll remember, that negative 5 tells us where this line intersects the y-axis. So it crosses somewhere, hitting the y-axis, and in our example, it's going to hit it at negative 5 right here. So that's going to be our first point that we're going to use to graph our line. Now the second value is that number next to the x. In our previous example, it was 2/3. Well, in this example, I don't see any number there. So if there's no number there, we're going to presume that that number is a 1. How many x's did we have here? We have 1x. So this number is just a 1. So let me go ahead and write our number off to the side. Now a second ago, we had a fraction. We had 2/3. So how would we take 1 and write it as a fraction? Well, to turn 1 into a fraction, we would just put it over 1. To turn anything into a fraction, you would just take the value of it and put it over 1. Now, if you remember, the top number and the bottom number both had a job to do. The top number determines the up or down movement for our next point that we're going to make. So since we have a positive 1, from this point right here, we are going to go up 1 unit. And then the bottom number is our left or right. And it's a positive 1, so we're going to go to the right 1. So we go up 1 and to the right 1. And that gives us a second point. We could continue this, by the way. We could go up 1 and to the right 1 again. Up 1 and to the right 1 again. Continue making points, but we really only need 2 points to graph our line. So I'm going to go ahead and just graph a couple here. Then I'm going to connect my dots here. And label my line as the line y equals x minus 5. Okay, let's look at a couple more examples. Let's check out the line y equals negative 1/2 x. Now notice this one looks kind of different from the last one in that we don't have this b value that's sitting over here. We don't have a plus 2 or some number, or we don't have minus some number. We don't have anything here. So if there's nothing here, this is going to be presumed to be just a big old 0. There's nothing here, so it's a 0. So this 0 has a job to do. This tells us where our linear equation crosses the y-axis. It's crossing the y-axis at 0. So here is our first point for this graph. Then we are going to use the number connected to the x, in this case this fraction, to figure out our next point. Let me write our fraction over to the side, negative 1 over 2. Remember, each of these has a job to do. The top number determines your up or down movement of your next point. Your bottom number determines the left or right movement. So starting here, the y value is negative 1, so our up or down is going to be down 1 unit. And then the number 2 underneath it is a positive value, and that's our left or right. That means we're going to go to the right 2 units. And again, I could continue going down 1 and to the right 2, down 1 and to the right 2, continuing that process. All of these points, notice they sit on the same line. So I'll go ahead and draw my line that passes through those points. And I'll label my line y equals negative 1/2 x. All right, let's look at one more. We've got the equation y equals negative 3x minus 7. The negative 7 is our y-intercept, where our line hits the y-axis. So I'm going to put a point right on negative 7 on our y-axis. The number connected to the x is going to be our slope. That's going to help us find our second point. So let me write it off to the side. Again, it needs to be written as a fraction. Since it's a whole number, to write any whole number as a fraction, we just put it over 1. And again, the top number and the bottom number both have a job to do. They help us find our next point. So our next point would be found by starting here and going down 3, since our y value is negative, so we go down 3 units, and to the right 1 unit. So our y, our bottom number here, our left or right movement is positive, so we're going to go to the right 1 unit. So we went down 3, and we went to the right 1, and we found our second point. Now I'm going to go ahead and grab my line and draw a line that passes through my points. Remember, these lines literally extend on and on forever and ever in both directions. So here's the equation that represents this line. Y equals negative 3x minus 7, and that is the graph of this line. So to kind of sum it up, remember, the number that's sitting off by itself, in this example, negative 7, is always where your line hits the y-axis. In this example, it hits it at negative 7. The number connected to the x is always going to be how you get your second point that you'd use to draw your line. From here, in this example, we had to go down 3 and over 1 because our slope, or our number connected to the x, was negative 3 over 1. Now, sometimes you're given a question that looks like this. Which graph best represents y equals 1/2 x minus 1? Well, from what we know about linear equations and how to graph them, the first thing we do is see which of these graphs has a y-intercept at negative 1, or which one of these graphs crosses the y-axis at negative 1. Well, this one is crossing the y-axis right here at 0. So we can get rid of this one. This graph is crossing the y-axis at negative 1. So this one here is a possibility right now. This graph here, this line crosses the y-axis also at negative 1. So that's a possibility. This graph here, its line crosses the y-axis. It looks like at negative 1. So here's another possibility. This one is not crossing it at negative 1 down here, so we can cross this one off. And this one, again, is crossing right at 0, so we can cross this one off. So we have basically 3 to choose from. So now we're going to use our value of m, our 1/2, to get our next point. So let's go ahead and look at our first example that was a possible value. 1/2 means I'm going to be going up 1, and I'm going to be going to the right 2 to get my next point. So from here, I'm going to go up 1, and I'm going to go to the right 2 to get my next point. Is this point sitting on the line? No, the line is way over here. So could this possibly be a representation of our line? Absolutely not. This one is a no-go. Let's look at the next one. Again, our y-intercept was at -1. Our slope is 1/2, or our steepness of our line is 1/2. So we're going to be going up 1 and to the right 2. 1, 2, right on this spot. Is that point sitting on our line? It absolutely is. So, the answer to which graph best represents this linear equation that we have is our graph letter O. So we have one more to try. I'd suggest you pause the video right now, see if you can figure out which one of these graphs best represents the equation y equals -x plus 2, then play the video to see if your answer was right. Okay, you should be back to the video now and checking to see if your answer is correct. So again, in this example, we're looking to see which of these lines best represents y, or which one of these graphs best represents the equation y equals -x plus 2. Well, again, we start with our y-intercept. Which one of these graphs hits the y-axis at plus 2? Well, this graph is hitting the y-axis right here, which is at 0. So, you can toss this one out the window. This one is hitting our y-axis, it looks like right at this point, at -1. Toss it out the window. This one also looks like it's hitting our graph at -1. Toss it out the window. This one's hitting our graph, it looks like at -1. Toss it out the window. This line looks like it's hitting our y-axis at +2. So this is a possibility. And let's look at our last one. This line looks like it's hitting our y-axis right at 0. So we can toss this one out the window as well, leaving us with only one answer left, and that is graph Q. We don't even need to check the slope on this thing, because the only graph on here that had a y-intercept of +2, or a line that hits the y-axis at 2, is graph Q. Okay, so I hope this quick and dirty examples of how to graph linear equations helps you on your SOL test. Good luck, everybody.